Hello and welcome to the Python Environments workshop. So this is being recorded as I am remote at the moment, so I couldn't make it in person. I am recording this on Halloween, and I would show you on my webcam what my costume is. However, I have a Dell XPS laptop and the webcam placement is kind of awkward. So for this video, I'm not going to enable it, but you can use your imagination. I am dressed as Freddie Mercury. All right, so for the actual workshop. So what are the motivations behind this? So what we'll be learning is we're going to be learning how to work with Python environments. Why you need to know this, it's important to know how to use them when working in different projects with different requirements. Where you will use this, you will use this anytime you're working on a shared Python project with other collaborators throughout your career. You can also use this when working individually, and you'll see kind of the benefits. All right, so a couple objectives for this workshop. So we're going to first understand the need for environments, and then we're going to go over two environment managing strategies. The first one being Venv, so the virtual Venn, and the second being Anaconda. So, understanding the need for environments. So you can consider the following scenario. So say you have an old Python 2 project with old library dependencies, but are now working with Python 3 and the newer version of the libraries. This scenario made a little bit more sense a couple of years ago when Python 2 still had some shred support, but I think nowadays uh, most most systems won't even let you easily install Python 2. You kind of have to go out of your way to install Python 2, but it may still apply to you, and nonetheless, you can still kind of extrapolate this to other uh, versions of, let's say, some popular library that you might be using, and they have their own dependencies, right? So if you're working with an older version that you can't upgrade for whatever reason, you might have to then use other libraries in older versions, and you don't want to mess with the projects that you have where you're working with newer versions of the same software. So, what is a Python environment? So, a Python environment serves as a sort of barrier that prevents files outside the environment from being used inside the environment. So, you're kind of containerizing different versions of software. You can, for example, have an environment for Python 2 and another one for Python 3. In this case, we just have like 3.x, but let's say you wanted to have one that was just Python 3.5 and then one for Python 3.6, you could do that, or you can get even more granular. Reason you might want to have that, for example, in the context of, let's say, being a Alberta student, is the lab machines don't always run on the latest Python versions. So you may have an environment dedicated to replicating the same environment run on the lab machines that you can develop on, while using a more newer version on other environments on your laptop. You can ensure the same version of Python and the libraries are being used by the team on a project. So you can kind of avoid the whole it works on my machine scenario, where it works for one person, but then as soon as you try to run the same program on a different person's computer, it doesn't work. You can segment libraries for example, UAIS projects, school assignments, and this is the example I named earlier, since the lab machines may not run the same Python version as your computer. And you can also segment libraries for other projects, of course. So one way you can capture your current environment is you can run pip freeze and pipe the output from standard out into a requirements.txt file. It doesn't have to be exactly this file, but that is the convention. And then if you want to use this file to then reinstall it on a different machine, you can do pip install with the R flag and then use that text file. So I can kind of show you the first command here. If I do pip freeze, this is what actually shows up. So this is all the current programs in my like default environment, and then I could save that to a file if I wanted to. Just to go back, here it shows you the exact version you have for each program, and so when you use this with pip install will go and fetch each version and will install that to whatever environment it's currently in. So first of all, we will go with the virtual env, just called venv. So I believe by default it is now part of the standard library, so you don't need to install it. So all you need to really do is you can just call it directly. So I can do like Python, call the module venv, and then I will give it a directory for where I want this environment to be saved in. By default, actually no, not by default, but by convention, a lot of people just call the folder venv. So it's kind of like you're repeating this twice. But the first one is actually calling the module, and the second one is actually the folder name. And then if I ls here, you can see that I have a folder name. Should run in a different directory, but if I just list the v, then you can see that I have a I have a folder right here. Should have went into a different directory, probably would have been easier. So I'll actually do that now. And I'll cd into my temp directory. I'll make a new directory. I'll cd into that. And I'll run that same command. There we go. And I'm not going to edit this out because I don't have editing software on my laptop. So here now there's this folder called venv, and if I ls inside of it, probably guess what the output is, but it's a couple files that actually configure things. Now, in this library, if I try to use this environment, it won't actually be used by default. Now, if I want to activate it, what I will do is I'm going to source it. To source it, I'll run source venv bin then activate. And I run this, and now it's being activated. Now my terminal gives me a nice handy little indicator right here that I am activated. And if I want to deactivate it, all I have to do is run deactivate. Oh, if I can spell it correctly, yeah, there we go. Deactivate, and that will deactivate it. But if I resource it and let's say install, actually, I'll deactivate just to show you something real quick to show that it actually is doing that correctly. So if I run Python and I do something like import numpy, you'll see that, oh, I don't have a module named numpy. Now if I activate it, and then I'll run that same thing again, still nothing because even this environment doesn't have it. But if I install it, now using pip install, it will install it to the environment automatically, so long as the environment has been activated. I can ignore that little warning at the bottom. But now if I run Python again, and I import numpy, you'll see I don't get that error anymore because numpy now is in my library. I can quit, and if I deactivate it, and I try going to Python again, try to import numpy, I get the module not found. That's kind of a quick demo of how venv works. Right. And here are the commands again, in case you didn't see them, right? You do Python called the venv module, and then you give it the folder you want environment to be saved in, and then you can source it, and then after you can deactivate it, you need to get out of it, and then you can just use pip install like you normally would. Now, some people choose not to include this their in their Git, so you put this folder in your Git ignore. Some teams might choose to include this to really make sure that everybody's using the exact same environment. So that's up to you, your team, and however you're deciding to manage your project. Next is a second way you can use to manage your environments, which is Anaconda. So I personally use something called Miniconda, which gives you Anaconda in the terminal, but it doesn't give you any of the GUI tools, which I think for most things this is fine. right? If you're coding anyways, right, you're probably using the terminal a lot, so might as well just use the terminal tool. No need to install any extra things on top of that. So what it'll actually recommend you do is you have to go on this website, and the installation is kind of not so friendly in that sense, but you go onto the website and then you'll go for whatever version platform you're on. In my case, for the latest Minicon installer, I am on Linux. So I will go for this 64-bit installer. I'll click on it. I'll save it. In this case, I'll save it to, oh, look at that. Save it to temporary. Perfect. So I'll save it in the workshop itself. A little bit easier, so I don't have to navigate as much. Right? And then I'll go back to full screen. There we go. Now, if I want to install it, I can just run bash and then name of the file. In this case, it wants to please read the license agreement. Of course, read the whole thing. It's actually not that long, so you can't afford to read it. It says, do you want to accept the term? Yes. It says here, where do I install it? In this case, I believe it's already installed, so it's just going to install it. I guess reinstall it. Well, this might be a slightly newer version. Who knows? I don't know when the last time it was I installed Minicon this machine. It's asking me if I want to initialize it. Sure. All right. And then it says if I want to change the effect to reopen my current shell. In this case, I'm not too worried about it because I already have it installed anyways. All right. So now, how do I use this? So you get a couple of choices on how to use it. So the way I find it most convenient is just conda create, and I'll give it a new name, right? I want to create something new. I believe there's a way of naming it on the list. Oh, no. Sorry, that's the wrong command. So conda list will actually just kind of do like a bit of a pip freeze. It'll kind of name what you have. So if I do conda create though, I give it the end flag to create a new environment. I can create an environment called, let's say, workshop. And it'll create one called workshop. It'll create this default location. You don't worry too much about the location. What I like about Conda is you essentially kind of have like these global environments that you can kind of reuse across multiple projects. And so if I'm in a different directory, I'll still be able to call the command and it'll start looking this location by default, and therefore it'll always kind of find the workshop folder. Now in this case, I'm gonna not proceed with it just to show you something cool. So something you can also do is when you're creating this environment, you can kind of tell it what version of certain libraries you want it to install. And with this trick, you can actually tell it which Python version to run, right? So I was saying earlier, you might want to have different libraries for different Python environments. So and the way you do this, and I'll just kind of run Python here real quick to show you what version I'd be running by default. In this case, 3.7.4, that's the default version here. So I do conda create work, give it the end flag workshop, and I'll do something like Python equals, let's do 3.10. Oh, I believe 11 is the latest version now. Now you can see that when it's to install Python, it'll install Python 3.10. And then I'll just go through the rest of the installation. And it's here showing me how to. So by default, Anaconda already has this Anaconda 3 environment already running. But if I wanted to run my new environment, I do kind of activate, if I can type, workshop. And now boom, you can see now it says workshop. Now if I run this same Python command, I can see it's Python 3.10, right? So now I have a new environment. And then again, I can do pip install, let's say numpy, for example. It'll install numpy, and I can run all sorts of other software that I want with different versions. And that kind of gives you an overview of how NumPy works, right? So it's not going crazy in depth into uh, how exactly they work and all the intricacies. Is more so to give you an overview of what you can do. Um, but of course, if you kind of want a little bit more of a deep dive, we do have a couple videos of the original Python environments workshops that we recorded. Playlist I can link to this video as well. Oh, actually, yeah. Almost skipped my own slides. I was getting ahead. So yeah, so if you have conda create, and you can give it the, for example, the Python version here, conda activate, testing with the Python version. Oh, yes, you can also do conda install instead of pip install. The main difference is basically the repository it's actually getting the software from. Pip will use it from, what was it? I forgot the repository. I think it's called pip. Can't remember the website. PyPy. That's. I knew it was something like PyPy. I just couldn't spell it in my head. So pypy.org. That's where it gets it from. Versus Conda, which will get it from the Anaconda repositories, and the Anaconda repositories have different channels where you can get the actual software from. But for everyday use, doesn't really, doesn't really make a huge difference. I honestly just use pip install because it's all really the same, at least for me. All right, and thanks for coming. So it says here next time posits, but I do believe it's not going to be that. It's going to be something else. I just can't say the top of my head. Man, Justin's going to kill me. I'm sorry, Justin. But Justin's going to be presenting the next workshop. And yeah, that's it for me, Gino. I will be back in Edmonton the next semester, so I hope to see you all. Have a nice day.